Alright, so in our last lecture, we discussed about the origin of the solar system. Today, we will be talking about the gravitational field strength of a planet. So, according to Newton, he said that the objects with mass attract each other through gravity. So, the force of gravity became what? Proportional to the masses, and it was inversely proportional to the square of the distance. What does it mean? That the further we go away from an object that has a gravitational field strength, the force of gravity will become lesser, right? And it's proportional to the masses, mean that the more the mass, the more will be the force of gravity. You get this part?
Yeah, I understand.
Okay. I'll show you one formula basically. It's not part of your syllabus, but just for your knowledge that why they're saying all of this. So basically the gravitational field strength force is like basically F is equals to capital G M1 M2 upon R square, where this is the mass between two bodies, and if you need to find the the force of attraction between two bodies, the gravitational field strength between two bodies, this is the formula that we use, where r square is the distance between those two objects or planets. So as you can see through this formula, the force is what? It's directly proportional to the mass, and it's inversely proportional to the square of the distance. Okay.
Yeah, it makes sense now.
Alright, so this is the formula that they are basically talking about. It's proportional to the masses. Masses means M1, M2. For example, let's say this is Earth and this is Moon. I want to find the force of attraction between the Earth and the Moon. So I use this formula where G is my constant. M1 would be the mass of the Earth, M2 would be the mass of the Moon, upon R square would be the distance between them. This would give me the gravitational field strength of the force of attraction between these two planets. Understood?
Yeah, I did.
Okay. Then the relationship between mass and force. What is the relationship between mass and force? I just discussed this with you. Greater mass results in a stronger gravitational field. What is the distance impact?
Yeah.
Having the distance between objects quadruples the gravitational force. So, as soon as we increase the distance, our gravitational force keeps on decreasing. So, the gravitational field strength on a planet depends on the mass, nearly uniform across the surface, and when we decrease strength and the strength decreases with distance, that is the gravitational field strength diminishes as the distance from the planet increases. Got it?
Yeah, I did.
So I'll write it more simply over here. Let's say the gravity or the gravitational field strength, I'll just write gravity, is inversely proportional to the distance, and it's directly proportional to the mass. Any questions, Alia?
No, not so far.
Okay. Let's move on. The travel time in the solar system. So, what do we know about it? The first point is the visibility source. So, the planets and moons are visible due to the sunlight reflection, where without the sun we would have never been able to view these planets and moons. And one minute, I'll come to this part. See this part. So the planets and the moons are visible from Earth only because they reflect light from the sun. The outer region of the solar system are what? 5,000 million kilometers from the sun, and even light takes time to travel to such distance. Do you get this part? Like the universe is so vast, it's so vast that even light feels that it's slow to reach this much distance.
Yeah.
Okay, so you need to remember this. And then we have this part. I already discussed the main things with you guys related to the planets that we have in our solar system. So they have written some more details over here. I extracted them out here in this part. So let's see what do we know so far about them. So the orbital dynamics, year duration increases with distance from the sun, and the orbital speed decreases with distance, and Neptune is slower than Mercury. Do you understand what does this part mean? The first 2 points, this part.
The further the planet are from the sun, the slower they move around the sun. So like the year duration, right?
Yeah, the year duration increases with distance from the sun. Okay.
Yeah, so the larger the distance, the year duration increases.
Exactly.
Yeah,
The further the planet, the more time it will take uh, to revolve around the sun. Okay.
yeah,
So then, what's the second part? The orbital speed. The orbital speed decreases with distance. Therefore, Neptune is slower than Mercury. Okay.
okay,
So
yeah,
the speed also decreases. So as Mercury is closer to the sun, so it revolves around it at a much faster speed than Neptune, which is very far away in the solar system. Got it?
yeah.
Then what do we have? The surface
Surface temperature.
temperatures. We have a general trend of surface temperatures, which is what? Remember the first four inner planets, and then we have the outer planets. The first four planets
Yeah,
are solid and rocky, and the temperature is also high, whereas the
outer
four
planets,
outer planets, they are cold,
they're colder.
large, and gaseous, right? So
Yeah,
what does the trend tell us about the temperature? That it decreases with the distance from the sun. The further we are from the sun, the colder the planet will be. Okay, so it's very general. If they ask you, you just need to know that the planet which is near the sun will have a higher temperature than the one that is further away from the sun. That's it. Except which one? I already discussed this with you. Except Mercury and Venus.
yeah.
Mercury is the
Venus is
first
hotter.
planet, whereas Venus is at the second number. But the temperature of Venus is way more higher than the temperature of Mercury. Why?
Yeah, dense CO2
Because
atmosphere.
yeah, because of the atmosphere, it's gaseous. So see, Venus has a higher surface temperature due to dense carbon dioxide atmosphere. Got it? So
Yeah,
what happens because of this? Dense carbon dioxide atmosphere acts as a heat trap, and the day-year relationship becomes very slow, which is around 243 days, and it has longer days. That got it?
yep,
Then what do we have? The Mercury's atmosphere and temperature. The temperature in Mercury is practically the atmosphere in Mercury is practically none because there is no gaseous atmosphere there on Mercury, and the temperature range is also around. See the difference? It's around 460 degrees Celsius. This is around 350 degrees Celsius. And at night, see how cold it gets at night. Even though it's so close to the sun, but see how cold it gets at night. It goes into minus
yeah,
170 degrees Celsius. Okay.
okay,
Then what do we have? Mars, Earth's nearest neighbor. It has a equatorial temperature that rarely exceeds 0 degrees in summer. So it's not too hot during summer. This is what they're trying to tell us. What about the atmosphere in Mars? The atmosphere is very thin, mostly carbon dioxide with traces of water vapor and oxygen. This is why all the scientists are in a rush to find out more tests and all other things to see whether Mars is habitable for the humans or not. Because of these things. Okay? Then what
okay.
do we have? The seasons and the geological features. I told you that the Earth is tilted at 24 degrees Celsius. At 24 degrees, resulting in seasons longer than resulting in a seasons longer than. I made an error in this sentence over here. Basically, resulting in seasons. Okay.
Okay.
Remember the axis? It revolves like this at
Yeah.
24 degrees. This still provides us the northern hemisphere and the southern hemisphere, and we get these two temperatures at the same time, and they keep on changing. I did this in detail with you guys. Remember?
Yeah, I remember a lecture.
Okay, great. Let's move on. Mm, this one is also. What's the current status of Mars? Comparatively, the activity level is comparatively inactive, and it has high winds at times causing dust storms. What else? What is the geological feature of it? It has polar ice caps. It has very large extent volcanoes, and there's also evidence of past floods on Mars. This is all Mars. Okay.
Okay, got it.
Oh, I'm so sorry, beta. Sorry. This tilt is for Mars. Okay, the Mars is at a tilt of 24 degrees, and therefore it has seasons which are longer than Earth. Got it?
Yeah, I got it now.
I am so sorry. Okay, I hope this part is clear. What's next? This is mainly theory. As you can see, you just need to memorize all these things, and they will be asking this only in the paper from you. Let's do a numerical. See this one? Let's try to solve this one. General numerical. Calculate the time of flight from sun to reach the earth. So how do we find it? We need the time of flight. So time of flight would be found using the general formula, which is velocity is equals to distance upon time. So the time of flight would be equal to distance upon velocity. So we know this. These are all constant values over here. The distance from the earth to sun is this, and the speed of light is always 3 into 10 to the power 8 meters per second. Remember? So you need to remember these values. These would come in handy. So if we want to find how much time does the light take to reach earth, how would we find it? We know the distance from the sun to earth, that is what? 1.5 into 10 to the power 11 over what's the speed of light? The speed of light is 3 into 10 to the power 8. If you calculate
So you just
this,
divide it, yeah.
yeah, what would you get? Should be giving you 500 seconds. When you convert it into minutes, it will give you around 8 minute 20 secondish. Calculated, let me know. So
8.3 minutes.
8.3, so 8.30 seconds or 20 seconds, around this much time it takes for the sunlight to reach earth. So if the light goes off, or if the sun vanishes, or it goes if the earth gets away from the light, we would get to know about it after 8 minutes 20 seconds. Like if anything happens to the sun, we won't get to know about it for another 8 minutes. Got it?
Got it.
What else now? This is what you need to remember. I'll make a frame of this as well. Now this part. I already did talk about all these things in detail with you guys, remember? When I was teaching about the inner 4 planets and the outer 4 planets. So these are some more important points, and I thought of like putting them in the notes part from here, from all this part. So have a look here now. So let's first talk about Jupiter. This is Saturn and its rings around it. This is a picture taken by Voyager 1 probe. This is a picture of Jupiter's great red spot, picture by Voyager 2 space probe. So let's find out what do we know about Jupiter. So we already know that it is the largest planet in the solar system, and it has a gaseous composition. So it is basically filled with lots of gases. Okay, it's a gaseous planet. It's very large. It's the largest in the solar system, and it has many moons as well. What do we know about Saturn? So it has rings and atmosphere. The spectacular rings are made of icy particles, and it has a turbulent atmosphere with hydrogen, helium, ammonia, and methane. So you need to remember the gases which can be found on Saturn. After this, we have Uranus and Neptune. The characteristics of these two planets are that they are both large, cold, and windy. They have small rocky cores surrounded by icy mass, which is basically what? Water, methane, ammonia. So do you see all these common gases that we are getting in all these gaseous planets?
Yeah.
Okay.
Yeah.
So remember this. So the atmosphere of Uranus and Neptune consists of methane, hydrogen, and helium. You need to remember this. Then the gravitational attraction, they both are able to retain lighter gases in atmosphere due to their large masses. So all these three gases are very light, right? Methane is what? CH4, and then we got what? Hydrogen, that's H2, and then helium. What about Pluto? I discussed about Pluto as well. Remember?
Yeah, I remember.
So it is part of the dwarf planets. So dwarf planets are smaller than our moon. The atmosphere consists of frozen methane and nitrogen. Remember this, okay? It consists of frozen methane and nitrogen. Let me see this part. Five moons, with Charon being the largest. The name of the moon. Let me confirm this. This was in, yeah. See this part. Pluto and its moons was obtained from New Horizons spacecraft by flyby in 2015. It also collected Jupiter's atmospheric system and moons on its outward journey. So Mars has been comprehensively mapped with global surveyor satellite. Do you see how many satellites we have out there which are taking pictures and getting more information about all these planets for us? So see, the dwarf planet Pluto is smaller than our moon. It is smaller than our moon and it has an atmosphere of frozen methane and nitrogen. It has five moons and the largest moon is Charon, which are thought to have formed in a collision between two dwarf planets early in the life of the solar system. So you need to remember this. And what does it look like? The reddish brown cap around the north pole of Charon was found to contain organic molecules which together with water can form chemicals needed for the evolution of life. Do you see this part? This detail is very important. You want me to elaborate it or is it easy?
No, I understand. It's
Understand?
crazy.
Okay, good.
Yeah.
Remember this part as well for Pluto. So, how did the moons form on Pluto? It is believed that they were formed in a collision between two dwarf planets, and this largest moon, it is reddish. It has a reddish brown cap around its north pole, and it contains organic molecules which are potentially relevant to life's evolution. Then we have a number of unmanned space missions in which we sent all these satellites and these spacecrafts into the space without humans in them. So what have they got us for? What information have they got us? See this part. Voyager 1 and 2, they provided information on the outer planets and the moons through flybys. Like they fly by the planets and they get all the details by taking these pictures. Then we got a Cassini spacecraft which orbited Saturn for 13 years and collected data on Saturn and its moons before plunging into the atmosphere in 2017. So they keep on revolving around the planets, and when their time is up, they just basically get destroyed. They fall back, fall into the atmosphere of those planets. Then we have New Horizons spacecraft, which fly by in 2015, and it provided information on Pluto and its moons, and it also collected data on Jupiter's atmosphere, its ring system, and the moons as well. Then the last part, this part, the closest planet that we have. Global Surveyor satellite mapped Mars comprehensively. So this satellite has mapped Mars for us, and the Spirit and Opportunity rovers. We have sent rovers as well in Mars. Do you know what are rovers?
Yeah, those autonomous vehicles which are
Yes,
in
which
the other planets.
yeah, they are moving in Mars, and they obtained extensive data on the Martian rocks. They brought rocks for us, and we got to study those rocks and get more details about them. So the Curiosity rover currently it is exploring the Martian landscape of Mars, and in 2018, InSight spacecraft landed in 2018. It recorded Mars quakes, providing insights into the planet's interior, like how does the interior surface of the planet function, basically. And then we got the last part, that is the Perseverance rover, which landed in 2021. This is recently, and it will. What's the purpose of this rover? It will search for signs of past microbial life and test powered flight with the Mars helicopter Ingenuity. Do you get this?
Yeah,
Easy.
yeah, it's pretty easy.
Properly learn all these things. That's why I set them up in points for you guys. Now this is this part, the gravity and planetary motion part. Let's talk about this. Alright, now gravity and planetary motion, the centripetal force in circular motion. How does the gravity act? Do you remember me teaching you about the centripetal force and centrifugal force? What causes all the planets to keep on rotating around the sun? Like,
I can't
you can't
recall it.
recall? Okay, I'll tell you again. For example, let's say this is you standing in the middle, you have a rope in your hand, and at the end of the rope, you have a rock tied at the end of the rope. So if you rotate your hand, what would be the motion of the rock? Circular, right? Like this. Do you get it? If you
Yeah, I got it.
if you
Yeah, I
hold
remember.
the thread in your hand and you like rotate it above you, the rock would be moving around like this. And as soon
Yeah,
as you let go the thread or the rope, what would happen? This rock will move on into a straight path like this direction, always 90 degrees, right? If this rock is left from this point, let's say this was over here, then it would be going in this direction as soon as you leave it, right? This is how the planets also work.
okay.
Over here, we have the, let's say this is the sun, and these are any planets over here. So what's happening basically? Let's suppose this is the sun, this is the earth. Oh, I'm so sorry. This is the sun, this is the earth, let's say. Now, let's say that the earth is being attracted towards the sun. So it came over here. Now, what happens? It tries to drift away from the sun, but what does the sun's gravity do? It pulls it back. Therefore, instead of going like this, the earth changes its direction and comes over here. Then it tries to go away from the sun from here like this. The gravity again pulls it in this direction. So it again changes its trajectory. Then from here it tries to go from here to this direction. Again, as soon as it reaches here, the sun's gravity pulls it back. And this is how the whole circular motion is generated. Do you get it?
Yeah, I understand.
Do you remember me teaching you this before as well?
Yeah,
Right?
I recall it now.
Yeah. So in this case, this force of attraction that is pulling the earth into towards the center, this is your centrifugal force. Got it? And the force that is exactly opposite to it
Yeah,
is the oh, I'm so sorry. So sorry. In a hurry, I wrote this wrong. This is centripetal. Okay, centripetal force, and this is the centrifugal force. Okay, so both are same. The only difference is their direction. That's why the Earth is not falling in the sun. Thanks to the centrifugal force, it is exactly equal to the centripetal force. That's why it generates this trajectory. The Earth tries to go away from the sun, it gets pulled back. If there was no centrifugal force, when the sun would have pulled the Earth towards itself, the Earth would have gone straight away in the sun. Then, correct?
yeah, I understand.
So remember this; it's very important. I'll do one thing. I'll put this also in part of our frame over here. That's pretty much. This is like one unit is over from this chapter now. In our next session, that's tomorrow, I'll cover up this whole part with you guys now. Okay? Stars and the universe, about the sun,
Okay.
stars, how are they formed. This is also important part, and then our syllabus will be complete. So I want you guys to solve this as many questions as you can from this part. It's very easy. So please complete it today only. It would be very good if you do it today only. Not today, like I know you have your paper. So within this week, by the end of the weekend. Alright?
Okay.